Chapter 9, Section 4 discusses selecting an appropriate sample size. Let me show you with the formula first what this is all about. If you recall, z is equal to x bar minus mu divided by the standard deviation of the sample means, sigma over the square root of n. If we multiplied both sides, or if we multiplied by sigma over the square root of n on both sides, then we will get here x bar minus mu on the right hand side, because the two expressions sigma over the square root of n will be cancelled. And if you recall, this is the error or margin of error. So this expression will be equal to the margin of error, and we can just call that E for the margin of error. Now we can multiply both sides by the square root of n. So on the left-hand side, we just have this, because the square root of n will be cancelled with the other square root of n. All right, on the right-hand side, E times square root of n. And if we solve for n, we will get z times sigma divided by the square root of n equals E. Divided by E. Equals the square root of n. And to solve for n, we just have to square both sides. So this will be square all of it. And then this one will have no square root. So n will be equal to that expression. So if we're interested in knowing what sample size we need in order to commit a certain specific error, and given a certain confidence level, which determines z, and of course, if you notice, we need to know the sigma, then we can find the minimum sample size. And that is what is discussed here. For example, a student in public administration wants to determine the mean amount members of city councils in large cities earn per month. She would like to estimate the mean with a 95% confidence interval and a margin of error of less than $100. The student found a report by the Department of Labor that estimated the standard deviation to be $1,000. Notice that the standard deviation needs to be given or estimated. So this is a value provided by previous studies. What is the required sample size? Well, in the problem, we're given the $100 for E, the margin of error, or just simply call error. The value of Z for a 95% level is not 1.96, as we have seen before. And the estimate of the standard deviation is 1,000. So we use the formula, just showed you. N is equal to this squared. So Z is 196, sigma 1,000, error 100. Square, that's 19.6 squares, 384.16. You round it up. And it doesn't matter how small the decimals are. And end up with 385. That's the minimum sample size needed. Okay, now you can also use this for the case of proportions. Here is the expression for the values of z given a proportion sample. This is a proportion sample, the difference with the proportion of the population, again, same as the numerator here, and that's the error, divided by the standard deviation of the sample proportions, which is the square root of p times 1 minus p over n. So if you multiply by the square root of p times 1 minus p over n, the same thing we did in the previous one, that is equal to the error, which is p minus pi. And let's square everything on both sides. So this will be z squared times p 1 minus p over n, because all of this was under the square root. When you square that, then it's just the square root disappears. That is equal to e squared. So if we solve for p, we just need to move to multiply by n on both sides. And then we divide by e on the other side. I don't have much space, so I'll skip a step here. And that is the formula. Except that if you notice, if we are trying to define what the sample size is, there's no way we know what the p-value is. So because this is from the sample, so this p is substituted by pi, the proportion of the population, if we know it. And if we don't know it, then we just simply insert the value 0.5. Okay, so let's use one example. The American Kennel Club wants to estimate the proportion of children that have a dog as a pet. If the club wants to estimate the estimate to be within 3% of the population proportion, how many children will they need to contact? Assuming 95% level of confidence, and that the club estimated that 30% of the children have a dog as a pet. Notice that 30% here is the population proportion. So my n is equal to pi times 1 minus pi times z over e squared, which is the same formula as given here. Pi, this will be pi times 1 minus pi times z squared over e squared, or z over e and then you square it. That's the same thing. So if you substitute the values, 0.3 times 0.7, 196 is z value given at 95% again, confidence level, divided by the error, which is 0.03 in this case. Square that, that give you 897 sample size. A study needs to estimate the proportion of cities that have private refuse collectors. This is another example. The investigator wants the margin of error to be within 0.10 of the population proportion. So that's my E. The desired level of confidence is now 90%, and no estimate is available for the population proportion. What is the required sample size? Well, if we don't have the sample proportion, the population proportion, we need to insert 0.5, as I told you before. So just put 0.5 times 1 minus 0.5 times, if you look at the Z table, when the confidence level is 90%, the value of Z is 1.645. So in your table, you need to look for the area between 0 and Z is half 0.90, which will be 0.45. And you should be able to confirm that that's the value, 1.645. And divided by the error 0.10 squared, that gives you 67.65, or approximately 68 cities. That's the minimum sample size. And that'll be the end of section 4.